Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you some important problem of NEET and JEE Main which comes frequently. Students, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT JEE exam and NEET confidently with a good rank. Now let's start about the class. A ball is projected from point velocity in meters second. So this is the question. Okay, a ball is projected from point A. This is the point A with velocity 10 meter per second. So this is the velocity perpendicular to the inclined planes. Okay, this is the inclined plane perpendicular projected as one, because range of the ball in the inclined plane. So you have to calculate this value. Now to solve the problem, I have discussed in the previous video that take this is along x-axis and this is along y-axis. I draw the picture here clearly. So take this is along x-axis, this is along x-axis, and this is along y-axis. So you have to calculate the range here. Now consider always resolve the velocity and acceleration along x and y direction. So here acceleration is along this, so this and this, and velocity along x and y. So velocity along x, initial velocity along x direction is 0. Initial velocity along y direction is 10 meter per second given. This is the velocity components, and acceleration component becomes this angle is 30 degree, so 90 degree, this is 60 degree, so this angle is 30 degree, so this component is cos 30 degree, and this is g sin 30 degree. So acceleration component x will be g sin 30 degree, and ay will be g cos 30 degree with negative, because y we take in this direction, so acceleration x in this direction take negative. So we get this. Now first we find the time of flight. Equal to, we know, 2uy by ay, magnitude of this. Time of flight always we use this formula, time of flight. So 2uy means 2 into 10 by ay means magnitude of this 10 cos 30 degree root 3 by 2, which is equal to 4 by root 3. So this is the time of flight. Now range means displacement along x direction. So displacement along x direction will be displacement along x direction Sx equal to uxt plus half ax t square, which is equal to ux means along 0t plus half ax means g sin 30 degree, that is 10 half, and t equal to 4 by root 3 square. So 16 by 4 40 by 3, so 40 by 3, this is the answer, 40 by 3. This is question 1. Next question. A particle starts from the origin of coordinates at time t equal to 0 and moves in the xy plane with a constant acceleration in the y direction. Its equation of motion is beta x square, its velocity component in the x direction This is the problem. I repeat the problem once again. A particle starts from the origin of coordinate at time t equal to 0 and moves in the xy plane with a constant acceleration alpha in the y direction. Its equation of motion is beta equal to y equal to beta x square. Its velocity component in the x direction becomes this. So path of the particle will be like this way. Y equal to beta x square. This is the path of the parabola. We know y equal to kx square. This will be the path of the parabola. So we can also repeat this. So this is the path of the particle and it starts from this, and its equation of motion y equal to beta x square. We know the condition of parabolic path will be the horizontal velocity remain constant always. Condition of parabolic path is velocity along horizontal remain constant throughout the projectile path, and acceleration be always perpendicular to the horizontal velocity. If 2 point is satisfied, then the path of the particle will be parabola. So normal projectile path, you see that suppose a body is projected here with velocity theta. Now the path will be this. In this path always horizontal velocity remain constant and acceleration is always perpendicular. So that's why the path is parabolic path. So condition of a path to be parabola is horizontal velocity remain constant always, and the acceleration of this path, acceleration of the path is always vertical, is always perpendicular to the horizontal velocity. This is the condition to be path. This is the condition of the path will be parabola. So here this is the equation of the path, which is parabolic path, equation of the parabola. Now given y equal to, we know velocity along x direction equal to dx by dt, and velocity and velocity along y direction is dy by dt, we know this, and acceleration along y direction equal to d2y by dt square, which is given alpha. Acceleration along y direction is d2y by dt square, and acceleration along x direction equal to d2x by dt square, which is equal to 0. Here acceleration acts always vertical direction, acceleration acts always in this direction, and horizontal velocity remain constant, and horizontal acceleration is 0. So horizontal acceleration becomes 0, and acceleration ay becomes here alpha. This is given. So from this equation, that is acceleration is completely vertical, so its horizontal direction acceleration is 0, and velocity as acceleration along this direction is 0, so velocity remain constant. Now equation is y equal to beta x square, so dy by dt, differentiating both sides in respect to t, equal to 2 beta dx by dt. Now again differentiating, we get, so this is u, this is v, this is u, and this is v. In terms of uv, you have to differentiating. The formula of u into v, you know, du by dt into v plus u into dv by dt. This is the formula of uv, you know that from basic mathematics. Du by dt into v plus u into dv by dt. So from this, if again we differentiating both sides, this is constant, this is u and this is v, so differentiation of this is dx dt, and this is constant, so we can write this dx dt and dx dt multiply dx dt whole square plus x into, when this is constant, derivative of this is d2x by dt square. Now d2x by dt square is ax, and this is ay, so ay equal to 2 beta, this is velocity along x direction, plus x into ax equal to 0, we know x equal to 0, so vx equal to, and ay equal to alpha, so alpha equal to 2 beta square, vx equal to alpha by 2 beta root over. So this is the answer. Root over alpha by 2 beta, this is the answer. Clear? Acceleration along x direction 0, acceleration along y direction is given alpha. So this is given. Acceleration along y direction is alpha, that is ay is alpha. This is ay. Next question. cell fired from the So we have to find the beta angle. This is the path of the projectile and this angle of projection is alpha. Now from a one result I have discussed that if this angle beta, then this angle also be beta, because this path is symmetric path and this is the height. So from this point this distance and this distance are equal. So this is the isosceles angle. This angle should be equal. Now one result is I have got one result I have discussed in previous videos, that if this angle the alpha and this angle beta, then tan alpha plus tan beta equal to tan of theta. Theta means this angle is given tan alpha. So tan alpha plus tan beta given here, alpha means this equal tan beta plus tan beta equal to tan alpha. So 2 tan beta equal to tan alpha. 2 tan beta, that is tan beta equal to tan alpha by 2. So beta equal to tan inverse tan alpha by 2. This is the option. If this angle is, the formula is, if this is the projectile path and if this angle is alpha and this angle is beta and this angle is theta, the result is tan alpha plus tan beta equal to tan theta. In this problem we use this result. Okay, in this problem we use this result. Next problem. Last problem. I repeat the problem once again. In the figure shown in the two projectiles are fired simultaneously. The minimum distance between them during their flight is this. Suppose this particle projected at 60 degree, this particle projected 30 degree. Now the path of this path will be in this direction, and this path will be like this way. What is the minimum distance between the two particles? So here we have to consider the relative velocity of the projectile. First we take, suppose this is the point, this is A and B. Suppose ux will be 20 or 60 degree, which is equal to 10 root 3. uay equal to and 60 root 3 by 2, that is 10. This is u and v, and this is uax equal to 20 cos 30 degree minus, if you take along this direction positive, so this direction will be negative, so minus cos 30 degree, that is minus 10 root 3, and uay equal to, which is equal to 10. So first we take the x and y component of the velocity of both A and B, and here acceleration of both, acceleration of A and acceleration of B both is minus g. Now if this is at rest, suppose this is at rest, then this body moves with a velocity along this direction with a velocity uab. Now we have to consider uab along x. Uab along x means uax minus u and the velocity of the B along this direction u bx equal to, as this is take as positive and this is negative, so this is negative, that is 10 root 3, and velocity along y direction will be 10. So now we have to consider relative velocity along x direction, so this become uay equal to root 3 by 2, root 3 by 2 equal to root 3 by 2, 10 into the 30, so this is 30 and this is 10, so uab of y equal to 20. Now if this is at rest, then the body moves with a velocity, the velocity of A with respect to B, velocity of A with respect to B will be now this body moves with a velocity this like this way. So if the body is at rest, then this body moves with the velocity of this, which is a straight line. So if the final path is this, B is at rest and A moves with a straight line in this way, whose velocity is this. UABX means 20 root 3 I plus 20J. This is direction. So if we take this is I, this is J, so in this direction, so here if this angle is theta, then this particle is at rest and this particle moves with velocity, with this velocity. Now this distance is given, so what is the perpendicular distance? This is at rest and this particle moves with velocity AB, because we get the velocity UAB, we get this result. So this vector will be in this direction. Now what is the shortest distance? What is the shortest distance? Shortest distance will be this to this perpendicular distance. This is the shortest distance, minimum distance. So this is the perpendicular distance. Now if we calculate the angle theta, then we can easily find this perpendicular distance. So the angle is tan theta equal to y component by x component. This is y, this is x. X component, this is x component, this is y component. So tan theta equal to y by x, which is equal to this. Tan theta equal to tan 30 degree, that is 30 degree. So we get theta equal to 30 degree. Now from this triangle, from the triangle we get tan 30, this is 90 degree perpendicular base and this is hypotenuse. So sin 30 degree equal to perpendicular by hypotenuse, so D equal to so this is the answer. This is the answer. Class, subscribe my channel to get such type of videos. Welcome. Thank you. Okay.